Hello and welcome back to the Master Civil Engineering. In this video, you will learn that how to find the stress increase below a uniformly loaded rectangular area. I have been given a question which states that a flexible rectangular area is subjected to a uniformly distributed load of 250 kilopascal. We have to determine the increase in vertical stress at a depth of z is equal to 3 meter under these 3 points, that is point A, point B, and this point C. Okay, first we will find the stress increase at a depth of 3 meter below point A. So for point A, this is the corner of this yellow shaded rectangular. Okay, and for this rectangle, length, this is A, this is 6 meter, width, this is 3 meter, depth at which we have to find the stress, this is Z, which is 3 meter. M, this is the ratio of length of rectangle divided by depth, that is A by Z, which is 6 by 3, which is 2. And N, this is another coefficient, okay, which is a ratio of width divided by depth, okay, this is 3 by 3, which is 1 meter. Okay, these two coefficients are used to find the influence coefficient from a table, which I will show you in the next slide. Okay, so we will use the table to find the influence coefficient. Okay, and after multiplying the influence coefficient with a uniformly distributed load, we will get the stress increase at this point A. Okay, because this point, this is at the corner of this rectangle. Okay, so this is the table. This is the table for influence coefficients for points under uniformly loaded rectangular area. You can download this table from the internet. Okay, so along the vertical, these are the values of M or N, you can take any one, and along the horizontal, again the coefficients N or M. So for our point A, the value of N, this is 1, and value of M, this is 2. Okay, so N, this is 1 here, and M, this is 2 here. Okay, so you can see that the value of influence coefficient for N is equal to 1 and M is equal to 2. This is 0.2. Okay, so stress increase at point A, this will be simply a uniformly distributed load multiplied by the influence coefficient, that is Q, multiplied by I, which is 250 multiplied by 0.2, which is equal to 50 kilopascal. This is the stress increase at point A at a depth of 3 meter. Now the next point, this is point B. Okay, this influence coefficient table, this is valid when the point is at the corner of a rectangle. Okay, so you will get the value of stress increase at the corner of the rectangle. So we have to make this point B corner of some rectangle to find the stress increase. For this, I will divide this large rectangular area into 4 small rectangles. Okay, so for point B, you can see I am dividing this large rectangle into 4 rectangles. The first rectangle, this will be of 6 minus 2.4, this is 3.6 meter, and 3 minus 1.2, which is 1.8 meter. Second rectangle, this will be 2.4 meter multiplied by 1.8 meter. Third rectangle, this will be 3.6 meter multiplied by 1.2 meter, and fourth one, this will be 2.4 multiplied by 1.2 meter. We will find the stress increase for all of these 4 rectangles at this corner point. Okay, at this point. So for first rectangle, length, this is 3 meter. Okay, and width is 1.8 meter. So M, this will be 3.6 divided by 3. Depth Z, this will remain same. Okay, so M is 1.2 and N is 1.8 divided by 3, which is 0.6. Again, you will use the influence coefficient table. Here the value of N is 0.6 and value of M, this is 1.2. Okay, so the value of influence coefficient, this is 0.143. For next point rectangle, that is 3.6 meter multiplied by 1.2 meter. Value of M, this is 3.6 divided by 3, which is 1.2, and N, this is 1.2 divided by 3, which is 0.4. So value of influence coefficient for N is equal to 0.4 and M is equal to 1.2. Okay, N is equal to 0.4 and M is equal to 1.2. This is 0.106. Okay, For the third rectangle, which is of size 2.4 meter multiplied by 1.8 meter, the value of m, this will be 2.4 divided by 3, which is 0.8, and n, this will be 1.8 divided by 3, which is 0.6. Again, using the influence coefficient table, so value of I for n is equal to 0.6 and m is equal to 0.8, this will be 0.125. Okay. After that, for the fourth rectangle, that is of size 2.4 meter multiplied by 1.2 meter, m is 2.4 divided by 3, which is 0.8, and n is 1.2 divided by 3, which is 0.4. Okay. So again, for n is equal to 0.4 and m is equal to 0.8, m is equal to 0.4 and m is equal to 0.8, this is 0.093. Okay. Finally, the stress increase at point B. Okay, this will be the sum of all of these rectangles, that is q into I1 plus q into I2 plus q into I3 plus q into I4. Q is same, this is 250 kilopascal, value of I1 0.143, value of I2 0.106, value of I3 0.125, and value of I4 0.093, which will give me the value of stress increase at point B equal to 116.67 kilopascal. Okay. After that, the next point which is remaining is point C. You can see this point C is outside this rectangular area. So what we will do, we will extend this rectangle up to point C. Okay, make a rectangle which passes through point C like this. Okay, so simply we are making a rectangle of size 6 plus 1.8, which is 7.8 meter multiplied by 3 meter. And from this, we will deduct this small rectangle, which is of size 1.8 meter multiplied by 3 meter. Okay, so first rectangle, this will be 7.8 meter multiplied by 3 meter for this value of m. This will be 7.8 divided by 3, which is 2.6, and this will be 3 by 3, which is 1. So we have to find for n is equal to 1 and m is equal to 2.6. We can see in our table the value of n, we have n is equal to 1, but we don't have value of m is equal to 2.6. So we have to interpolate between 2.5 and 3. So for n is equal to 1 and m is equal to 2.5, okay, we will get the value of influence coefficient 0.202. And for n is equal to 1 and m is equal to 3, the value of influence coefficient is 0.203. Interpolate between these two, that is for n is equal to 1 and m is equal to 2.5, influence coefficient is 0.202. And for n is equal to 1 and m is equal to 3, value of influence coefficient is 0.203. From interpolation, you can say that for n is equal to 1 and m is equal to 2.6, you have to do the linear interpolation. Value of I, this will be 0.2022. For the next rectangle, for point C, which is of size 1.8 meter multiplied by 3 meter, value of m, this is 1.8 divided by 3, which is 0.6, and value of n, this is 3 by 3, which is 1 meter. Again, use the influence coefficient table. So for n is equal to 1, okay, and m is equal to 0.6. The value of influence coefficient is 0.136. So stress increase at C, this will be stress increase at the corner of this large rectangle multiplied by, subtract minus stress increase for this small rectangle at this corner point C. Okay, so it will be 250 multiplied by 0.2022 minus 0.136, which is 16.55 kilopascal. This will be the stress increase at point C at a depth of 3 meter. Okay, so this is how you can find the stress increase at any depth below a uniformly loaded rectangular area. Okay, you just have to make the point at which you have to find the stress increase, the corner of the rectangle. Okay, and after that you will use the influence coefficient table to find the influence coefficient, which will ultimately give you the stress increase at that point. Okay, so I hope this solution video was clear and effective, and you definitely learned something new. If you found this video helpful, you can subscribe to my channel and share this video. And also, if you have any doubt regarding this solution video, you can write your doubts in the comment box. Okay, and I will be happy to answer your doubts. Thanks for watching and stay tuned.